Hello everyone. Today we are going to see the how to calculate the flexural strength of concrete. So we have casted the beam and now we are going to calculate how to calculate the flexural strength of the concrete by flexural testing machine. Okay. So here we are going to learn what is here we are going to learn what is flexural strength, why flexural strength is going to be performed, and where the flexural strength is going to be performed. And also we are going to see how to calculate the flexural strength of the concrete beam by third point loading according to the code ASTM C78. So here you can see the dial gauge in which it will represent the load. So here the flexural strength is one measures of the tensile strength of concrete. It is a measure of an unreinforced concrete beam or slab to resist failure in bending. It is measured by loading concrete beams with a span at least 3 times the depth of the beam. The flexural strength is expressed as modulus of rupture in PSI, that is MPa, and is determined by standard test methods according to the
5004
ASTM C78, that is third point loading, or ASTM C293 center point loading. Flexural MR is about 10 to 20% of compressive strength depending on the type, size and volume of coarse aggregate used. However, the best correlation for specific materials is obtained by lab. So here the modulus of rupture determined by third point loading is lower than the modulus of rupture determined by center point loading, sometimes by as much as 15%. Now, why we need to test the flexural strength of concrete beams? So designers of pavements use a theory based on flexural strength. Therefore, laboratory mix design based on flexural strengths may be required, or a cementitious material content may be selected from past experience to obtain the needed design of modulus of rupture. Some also use modulus of rupture for field control and acceptance of payments. Very few use flexural testing for structural concrete agencies not using flexural strength for field control generally find the use of compressive strength convenient and reliable to judge the quality of the concrete as delivered. Next, how to use flexural strength. Beam specimen must be properly made in the field. Concrete mixtures has to be stiff. The beam specimens must be properly made in the field. Pavement concrete mixtures are stiff. 1/2 to 2.5 inch lump has to be required. Consolidate by vibration in accordance with ASTM C31 and tap sides to release air pockets. For higher slump, after loading, tap the molds to release air pockets and spread along the sides to consolidate. So here it is a third point loading. Half of the load is applied at each hertz of the span length, and you can see here the cracks that is going to be measured after applying the third point loading on each third of the span of the length of the beam, and maximum stress is present over center 1/3 portion of the beam. So you can see here, this is the dial gauge. So here the specifications and investigation of apparent load strengths should take into account the higher variability of flexural strength results. So you can see here the cracks that are clearly visible after applying the load on the 1/3 point loading from the span. So you can see this is the dial gauge. So you can see after application of load, gradually the cracks has been formed on either side of the beam to calculate the flexural strength. The standard deviation for concrete flexural strength is up to 800 psi, that is 5.5 MPa for projects with good control range from 40 to 80% psi. Standard deviation values over 100 psi, that is 0.7 MPa, may indicate testing problems. There is a high likelihood that testing problems or moisture difference within a beam caused from premature drying will cause low strength. So when the load is applied on the beam, the deflection is going to be measured at the bottom of the gauge we have fixed when gradually the load is going to be applied, where a correlation between flexural and compressive strength. This is the highest kg for 20,000 kg per force is going to be recorded for this flexural strength. Now you can see here the cracks has been developed on the either side of the beam, where a correlation between flexural and compressive strength has been established in the laboratory. Core strengths by ASTM 42 can be used for compressive strength to check against the desired value using the ACI 318 criteria. So you can see here, this is the cracks have been marked with the marker to see clearly visible the cracks after taking the force of about 20,000 kg per force. So this is the cracks has been observed on the other side.
Now it is not there. The load is removed.
So this is the part 1, testing of flexural strength of the beam. So in the next part 2, we are going to do the calculation, how to calculate the modulus of rupture of the beam. Okay, thank you.
Not visible, bro. Invisible cracks. Invisible. That